Hello, everyone. Thanks for joining today's live training. We're going to kick off today's session in a minute or so. But in the meantime, we'd love to hear from you. So let us know where you're joining from in the comments. And yeah, tell us what you'd like to get out of today's webinar. Just a note that today's live training will be hosted on DataCamp Workspace. So if you don't have an account yet, please register for a free account. I'll share a link in the chat shortly so that you can get one, and I'll also be sharing a link to today's challenge and solution workspace so you can follow along and code along with us. Alternatively, you can scan the QR code in the top left. Brilliant. I'll be back shortly. Hello, everyone. I'm Reese. I'm the moderator for today's live training. We're going to kick off in about a minute or so, but in the meantime, we'd love to hear from you. So ping us in the question box and let us know where you're joining from. I'm also going to post a link to our workspace for today. So make sure you can either scan the QR code or check the comments for the link to the challenge and solution workspace so you can follow along. We're going to get started very shortly. Okay, hello everyone, and welcome to today's live training. I'm Reese, your moderator, and we're just about ready to get going. We'll have first an intro from our data evangelist in residence, Richie Cotton.
Hi there, data scamps and data champs. This is Richie. Glad you're all here today. Before we get going with the session, I noticed there are a few questions in the chat, and of course, very good to see you calling in from all around the world. Simon was asking, is this webinar exclusively for DataCamp members? No, it's not. Anyone can join this session. However, we will be using DataCamp Workspace to code along, so you're going to need to sign up with Workspace. You need to register for that. Reese will post a link in the chat shortly, so you can get signing up if you haven't already. Also, Redisai is asking, please provide me a job. I'll give my best. That's great. DataCamp does have a jobs platform. So if you want to sign up to that, you can put your profile on there and then employees will find you. This is exclusively targeted at data analysts, data scientists, and other data jobs. So please do sign up for that. Again, I think Reese can post a link to our jobs platform shortly. All right. And with that, let's get on with the session. So today we're going to be talking about categorical data. And a lot of the time, data science, we seem to put a lot of focus on working with numbers, but categorical data is also really common. It's pretty much everywhere. So what we're talking about in the session today These are essential skills. You need to be able to analyze categorical data, whether you're working in business, working in science, or using today's example, it's social sciences data set. So pretty important for everyone. You need to be able to do this stuff blindfold if you want to work as a data analyst or as a data scientist. Now, instructing you today is one of our regulars. He's Justin Saddlemeyer, one DataCamp's workspace architect. And Justin's a data scientist, and he's also heavily involved in creating the workspace platform that we're using today. So I'm going to be quiet, and over to you, Justin.
Okay. Thank you very much for the introduction, Richie. Hello, everyone. Okay, so if it's possible, okay, here we go. So I've got some slides prepared. So just sort of to go over what we're going to be covering today, as sort of Richie said, our primary goal is to learn how to work with and update categorical data in Python. Our secondary goal will be to actually use these categories we've cleaned up and created to perform some light analyses and visualizations. Why? It's also sort of what Richie dove into. It's everywhere. It's really important to be able to use both for basic analyses, but also for machine learning. Basically, almost every element of analytics, you'll probably encounter categorical data, and it's a really important to be able to work with. So I believe the workspace has already been shared with you. I'm going to navigate to that page now, and I'll share my screen. You should be able to see a workspace that I've prepared here. I have open. For those of you that aren't familiar with DataCamp Workspace or notebooks in general, this is a cloud-based code editor. It's composed of a combination of mostly text cells and code cells. So if you look inside here, this is actually a text cell. If I double click inside of it, you can see that I've got a bunch of formatted text, which I formatted with a language known as Markdown, but you can also use this toolbar to format your text this way as well. Now, to run a cell, or in the case of a text cell, render it, you can use Shift Return, which will render it and highlight the next cell. We also have code cells, which is where we're going to be doing all of our work with categorical data. So same thing, when you edit it, you can then run it by clicking the cells on the side or using the shortcut, which for me is going to be Shift Return. Before I dive into the actual analysis, I'll just go over a few other things. We have the option to add SQL cells and chart cells. We won't be touching those today, but if you have SQL integrations or you want to use one of our sample integrations, you could always connect to a SQL database and run SQL queries, which will return the results of your SQL queries as a data frame, which you can then work with in Python. We also have chart cells to create no-code chart visualizations, or no-code charts. We won't be doing those today. We'll be making our own charts using primarily Plotly, but you do have the option to create line charts and bar charts with no code. One other thing I'll cover before we jump into our analysis is this side panel. When you're done with your report, you have the option to create a publication, which will create a read-only version of your report, which when used in combination with the hide code buttons and hide output buttons on the side of cells, means you can sort of tailor what people see. You can hide some of your gnarly Python code and just create a nice read-only report that you can share with people, especially non-technical audiences. We also have our file browser where we have our notebook, and we also have our data file. This is GSS_sub. This is a CSV. This is the survey data we'll be working with. The final two options in the side panel, one is integrations. This is more for environmental variables and SQL connections, which we won't be using. And then we have an environment panel, which shows all of the currently available packages and their versions that are pre-installed. Okay, so today we're going to be working with data from the General Social Survey. This is a large survey run in the US that is dating back to the early 70s. The full data set is enormous. I've provided a link to it on Kaggle, but I think it has something like 10,000 rows, so it's very challenging to load in and work with. So I've created a small subset of this data and cleaned up the column names to make it a little bit easier to work with. I've already added the packages that we'll be using today. We'll mostly be using pandas. I'm also importing NumPy. I don't know if we'll even use it, but it's always nice to have NumPy available in case you need to use any of the functions there. As I said, we'll be doing most of our visualizations with Plotly. For those of you familiar with plotting in Python, you may have used matplotlib or Seaborn before. I quite like Plotly because it allows you to quickly create interactive charts, and I think they generally look pretty good out of the box. We are going to also use stats models and matplotlib for one special chart type, which Plotly doesn't cover. And with that, let's begin by loading in our data. So I'm going to create a data frame, and I'm going to use pandas read CSV function, and I'm going to pass in the name of the file, and then I'm going to preview it. For those of you who are used to working outside of Workspace, you might use the head or tail method to look at the top or bottom of a data frame. In Workspace, you can just run the whole thing, and it'll return an interactive table like you see here. It's not going to show everything if it's an enormous data frame. So here we have about 500 or 59,000 rows. It's only showing 1,200 of these. But the nice thing is that this is paginated across pages. And you can skim through it. But the other nice thing is in previewing your columns, you can actually filter and sort. So let's say I wanted to look for all values of the labor status, which is are from people who are retired, or if I want to sort by the number of siblings in the household, you can do that. Of course, these are things you could accomplish with Python code, but it takes time, and then you might want to delete it afterwards if you don't want to share it. So it's a nice way to be able to quickly skim your data. Okay, so we've loaded in our data. We've set it as a data frame called DF. The next thing that you might want to do, and I commonly do, is try to take a look at a summary of the data frame. And a good one to use is the .info method. If you run this, what you'll get is a number of things. You'll get all of the column names that you see here, but you'll also see the number of non-null values. So you can get an idea of if there's a lot of missing values in certain columns. The other thing you'll get is the data types. So we can see that we have two data types in our data frame. We have floats, which are all the numeric columns. So year, ID, number of siblings, age, etc. And we also have objects. These are all the columns that contain text. So an object data type is something that contains text in pandas. One final thing that we're going to want to pay attention to is the memory usage of the data frame. So we can see how much space it's taking up in memory, which in our case is about 7 megabytes. And we'll pay attention to that later because we're going to try and optimize that when we change some data types. Okay, so this sort of gives us a nice overview of the data frame, but what if we want to inspect individual columns? Well, there's a number of ways we can do that. One is to use the describe method of the data frame. Now, by default, the describe method will only provide descriptive statistics of the numeric columns. If I use describe without any arguments, and I run this, you'll see that it's only providing me information on the numeric columns. So year, number of siblings, age, etc. And it's providing us a count of the non-null values. It's providing us the mean values, the standard deviation, the minimum, the maximum, and the various percentiles. But in our case, we're mostly interested in categorical data in this session. That's what we're going to be focusing on. And you can actually get a different summary of your data if you change what data types to include. And here I'm going to set this to include to be O, which is short for object. And now if I run this again, I'm going to get a summary of all of our object columns. And you'll see that the summaries are actually different. They're not providing the same summaries. So what we're getting is we're getting all of the counts of the non-null values, but we're also getting the number of unique values within each column. So we already know that within the self-employed column, for instance, there are 4 unique values. There are 6 unique values in degree, and so on and so forth. It also provides what they call the top, but it's basically the mode. It's the most frequently occurring value, so that we know the most common responses come from people who are married. Most common labor status is working full-time, et cetera, et cetera. You'll see for these opinion variables, they're providing IAP, which stands for inapplicable, which basically means it was incomplete or not filled in. So we'll deal with that later. And then finally, we have the frequency of the mode, or the frequency of the most occurring values. So there, of the 59,000 labor statuses provided, 29,000 reported working full-time. Okay, so we've already sort of dove in and given an inspection of just the categorical columns. But what if we want to inspect like one column at a time? Because it's nice to know what the mode is for example, the labor status column is, or the any other of the columns. But what about the other ones? What's the distribution of the other values? And a very useful method, which you'll probably use a lot, is the value counts method. So if I take one of our categorical variables, I'm going to use environment, which is an opinion about the government spending on the environment. And I use value counts, and I run this. Might take a second to run. Here we go. We'll get the value counts in descending order of the different categories. So we can see the most common is inapplicable. So it seems like a lot of people didn't fill this out, or the data was unusable. But then we say the most common response was too little, then about right, which seems that they're satisfied with it, and too much. So we can see that there's basically 3 responses people can give. They can also indicate don't know, but that's not a very useful one. So it's largely, is it too much, too little, or just right? Another handy thing you can use with value counts is you can also pass in an argument to the normalize parameter. So if I set normalize to true, we can get the proportions. So all of these will add up to 1. So sometimes it can be a bit hard just looking at the raw counts and understanding what proportion of that categorical column is one particular value. But by using normalize equals true, you actually get these as a proportion, which can make it really can be really helpful for things like visualization later on. And we'll actually take advantage of that. Okay, so now we have gone over sort of how to inspect our categorical columns. We've given a summary of them. Now we might want to start cleaning and tidying them up so we can prepare them for visualization. One of the first things we're going to do is change them from an object data type to a categorical data type. And the reason we want to do this, the primary reason, is it greatly reduces the memory usage, especially for categorical columns that don't have a lot of values. So you can see from our summary, there's not a ton of categories per column. That's when you'll get the most memory savings. If it's a really long, like open-ended answer, and you've got tons of different spellings and tons of different values or possible values a category can take in a column, then the memory savings are actually reduced. But in our case, it's actually a perfect opportunity to convert this to a categorical data type. Another nice thing is you can specify the order you want the categories to appear in. So oftentimes by default, the categories, when you go to visualize them, might go in an order that you don't like. So for example, an ordinal variable, which is a categorical variable that contains an inherent order. Consider, for example, age ranges. Let's say you have young, middle-aged, and old. Well, by alphabetical order, those aren't actually going to go in the order you'd like. But for a plot, it might actually make sense to have young, middle-aged, and old. Well, by setting the data type to categorical and manually setting the categorical order, you can preserve that, and it really makes visualizations down the line a lot easier. One other reason why you might want to use categories, a categorical data type, is it also is compatible with a number of other Python libraries. I believe there's some statistical packages that also make use of categories. So it can also be helpful when working with those. So what we're going to do is we're actually going to iterate through our data frame, and all of the object columns, we're going to take them and convert them to a category. So what I'm going to do is I'm going to create a dictionary called conversion_dict, and I'm going to use what's known as a dictionary comprehension, which is going to create a number of key value pairs where the keys will be the names of the columns we're converting, and the values attached to each key will just be category, because that's what we want to change them to. So the way I write this is k category. So this is the key value pair we want for k in. And then we're going to iterate through, or we're going to basically retrieve a list of the column names of object columns. So I'm going to use the select dtypes method. I'm going to only select objects, and then I'm going to use dot columns, and this will retrieve a list of object columns. And then essentially what we're doing is we're iterating through it. So each value of K, so for each column name, we're going to give it a value of category. And I can even show you what this will look like if I run this. So here we've got all of our object columns, and then the accompanying value of category. So this is what we're going to use to tell pandas to convert all of our columns. So then I'm just going to reset our data frame as type conversion bit. So I'm going to use the as type method, pass in our dictionary, and this is going to tell pandas to take all of our columns named as the keys and take the associated category and convert them to the category. So if I do df.info, I should be able to see that indeed we've converted all of our objects to categories, but even more importantly, we've halved the memory usage of the data frame, which will make subsequent operations a little bit quicker and snappier and easier, and especially when you're using for even larger data sets, those memory savings can be pretty helpful when you're performing operations. So we already see an advantage to converting the data type. Okay, the next thing I want to cover is cleaning up some of the columns where I think there's a lot of values. So basically what we're going to be doing is we're going to be collapsing categories. So if, and I'll provide an example of this. Let's take our labor status column, and I'm going to use the .cat accessor and then type in .categories. And this property is going to show us all of the possible categories that are currently in this, assigned to this column. So if I run this, we see that we have quite a few, but there's a bit of overlap. So you have unemployed, laid off, but temporary, not working. I mean, you could subjectively treat those both as unemployed, working full-time, working part-time. Those could be subjective as well. You could also just say that they're employed. You could also lump other ones together, but I think the ones we're going to do is the employment, whether they're employed or unemployed. And the reason we're doing this is just for visualization purposes and for analytical purposes. It's going to simplify things. If we have a ton of categories with small numbers of people, it's harder to draw insights and conclusions from it. But if we lump them together, as long as we're not losing any important information, it can be a nice way to simplify things and visualize them more clearly. So I've already defined a dictionary just to save on typing called new labor status, where the keys are the existing column values, and the values are what I'd like to rename them. So for everything that's unemployed, laid off, everything that's temp not working, I'm going to convert both to unemployed. And for working full-time and working part-time, I'm going to convert that to employed. So I'm going to collapse the number of columns. Now, unfortunately, we're going to need to quickly convert it to an object and then back to a category, because there's not a nice method, at least now to the best of my knowledge, to convert, to collapse categorical data type without first converting it to an object. So what we're going to use is I'm going to create a new data frame called labor status clean. I'm going to set it to our original column. And then the reason I'm doing this is just because it's nice to preserve the original column. I'd like to keep my labor status column originally in case I want to refer back to it, or in case I regret my mapping or something goes wrong. I'm going to create a variant of it called clean. I'm going to use the replace method, and I'm going to pass in new labor status. Now this will return the column as an object, so we also need to again set it as a category. But now if we take our labor status clean column, and I use the value count method as before, we should, oops, I need to pass this as a string. There we go. Okay, so what I've done is I've taken this dictionary, supplied it to replace, and replaced the values in the data frame. And now we see that we have a reduced number of categories within the column. So now we just have employed and unemployed rather than the additional laid off, not working, full-time and part-time distinctions. So when we go to visualize things a little later on, it'll be a little bit easier. Now, before I go on, another reason you might want to collapse columns is when you have a ton of different possible values in a column, you may just want an other category. So imagine you've added a survey and you've asked people for, I know their employment status, and most actually provide these, but then people provide, there's an other category, and people provide tons of written explanations of what their possible employment status. You might want to, for some of the strange edge cases of the long tail, condense all of those back down to another category. So there's a lot of applications for doing this. In our case, we're just taking the 8 categories and reducing them down to 6, but it can be really helpful when you have a ton of different possible values within a categorical column. Okay, the next thing I'm going to do is reorder some categories. So as I mentioned before, it is often useful to set the order of a category just for visualization purposes, especially for ordinal variables. We have such ordinal variables in our opinion data. So if I bring up my environment column, use the cat accessor and then the categories property. Just wait for this to run. Seems to be a short delay. Here we go. We have our categories here, and you can see they're in an alphabetical order right now. They're not in sort of the logical order of too little, about right, too much, and then the additional ones of don't know or inapplicable. So we're going to actually clean that up. And what I'm going to do is I'm going to actually loop through each of the columns that we want to change. So I think we're going to focus on environment, law enforcement, and drugs. All of them apply to people's opinion about spending on these particular problems or topics. So I'm going to say for call in, and then the names of the columns, which is environment, law enforcement, and drugs. And then don't forget to add a colon there. We're going to iterate through each of them, and then I'm going to create a new column, and I'm going to define that using string concatenation. So what I'm doing here is I'm going to take environment and then add underscore clean using a plus sign. So we're going to create a new column called environment clean, and I'm going to set that equal to the original column. So I'm going to subset that with call, and then I'm going to use .cat to use the category accessor, and then reorder categories. Oops, I can spell it correctly. And in that, we want to supply our new order, which is the order I've defined above, where I want it to go from too little to about right to too much, and then finally don't know or inapplicable. And one other thing you need to do to treat it as an ordered variable is you need to set the ordered parameter to true. One other thing we'll do while we're looping through this is I'm going to take our new column, and I'm going to set it equal to the new column that we've created in the row above, but I'm going to use the cat accessor again, and I'm going to remove categories. And I'm going to set the categories to autocomplete's not helping out there. So what I'm doing here is I'm also going to remove these categories that we've defined here. And when you remove a category from a column, values that are in that category are actually going to be returned as nulls. And the reason we want to do that is later we want to analyze this survey data, but I'm not really interested in people who didn't have an opinion or who did not get asked it at all. We just want to focus on people who've provided an actual response about whether they think it's too little, about right, or too much. So if I take our data frame, and if I've done it correctly, have it as environment clean, and then use cat.categories, we should see that we have our the 3 values that we want in the order that we'd like. So we've set it to too little, about right, and too much, which will help us with visualization later. Another sense check we can do is we can actually look at the value counts, and we can set drop NA to be false. And what this will do will also include the value counts of NANs. So we've got a lot of missing values now because we've gotten rid of all of those inapplicable responses that were in the original column. So if I remove this and run it, you'll see that we didn't have that many NANs before with the original column. But by dropping those columns, we're rendering them as null, or NAN. So they won't be counted in our future aggregations, but now they're all NANs. Okay, so we've cleaned those up a little bit. Next, we'll apply all of these steps in one cell to one other categorical variable, which I want to look at later, which is the degree column, which is people's education level. Because again, we have this same sort of thing where we have two different types of high school, and we've got different versions of college and university. And what I basically want is just two categories. I want high school education, or if they have any college or university education. So I'm going to create a column called degree clean. I'm going to set that to the degree column. I'm going to replace using the new degree dictionary that I've defined above, just as we did before. And I'm going to set it as a category data type. I'm going to remove, well, I'll just copy and paste this. I'm going to copy and paste this. And set this to the same thing, but cat.remove categories. And I'm going to pass in DK. We want to remove the don't know. And what else am I going to want to do? I'm going to want to also reorder the columns. So again, we'll set it and we'll use the .cat.reorder categories. And the order we want is high school, and then we want college, university, and we'll set ordered equals true. And then we'll just do a final sense check, again, using value counts. As I said before, it's a pretty useful method to double check that you've done things correctly. So indeed, we've categorized things. So we've got two categories now. We've collapsed everything down to high school or college and university. And we'll use this later in one of our plots. Okay, one final operation that I'm going to go over today that can sometimes be useful is the process of binning data. And this is taking quantitative data and binning it into categories. You won't always want to do this because you lose a lot of information. In our case, we're going to bin the dates, so the years. You lose a bit of information because basically 1972 is going to be in the same category as 1979. But a nice advantage of this is it can sometimes simplify data, make it easier to spot trends. And again, for visualization purposes, it can kind of be nice. In my case, I'd like to visualize a trend over decades, and I don't really want necessarily the noise that you might see through the years. I'd like to just sort of get an average per decade. So what I'm going to do is bin our year data into decades of 70s, 80s, 90s, 2000s, and 2010s. I've already set the decade boundaries and the decade labels. The decade boundaries is a list of tuples that show the bin ranges. So from 1970 to 1979, 1979 to 1989, and so on and so forth. You'll see that there's overlap between them, but how this works is it's going to yield one bin for the 70s, and then 1980 to 89 will actually end up being 1989 will be the 80s, and so on and so forth. So I'm going to create bins, and I'm going to use the interval index from tuples function from pandas, and that's going to take our list of tuples to create bins. So decade boundaries. And then I'm going to use the function cut. So I'm going to take df decade. So this is a new column, and I'm going to set it equal to pandas.cut. So using the cut function, we're going to pass in our year, which is what we want to cut up, and we're going to pass in the bins. So this is going to say how to cut it, on what range. Now, if you look at it as it is now, unfortunately, what's going to happen is you're going to see that the values make sense, but they kind of look ugly. I think the data type within this series is actually going to be an interval index. Normally, when you use pandas cut, you can provide labels, but for some reason, I'm not entirely sure why. You can't pass labels if you've used an interval index to split up your bins. So we're going to need to manually do that after. So I'm actually going to use .cat.rename, and I'm going to pass in the decade labels. And I'm going to use in place equals true just to save myself setting df decade equals df decade dot cat dot et cetera, et cetera. So this is just going to modify the series in place. And then we can preview the new column. So what I'm going to do is I'm going to actually preview the year and the decade of our data frame. Did I do something wrong? Hold on. Oops, rename categories. Sorry, I used the wrong method name. So now we can see for all values of 1972 through to 78, we're categorizing it as the correct decade. If we take, if I use the query method just to check another year, because you'll see that because the data frame is truncated, we've only got rows from the 70s. But if I want to set this to something like 1990 and make sure that it's working on the bin edges, we can also see that 1990 is correctly being classified as the 1990s. So you can do some sense checks by using the query method. But basically what we've done is we've converted the year column and just chunked it together by decade, which we can use for visualization later. Okay, so yeah, we're at about 36 minutes. So I think, Richie, we can take some questions.
Yeah, we've got a few good questions from the audience already. And if you do have a question for Justin, please ask them now. I'll try and get to them. All right. So the next question. There's a question on how to edit cells, saying command is inactive. If you look at the top of the workspace, so for example, on Justin's screen, it says ready and then Python at the top left. If it says inactive, you might there should be a button that shows up that says restart your workspace. So you might need to do that. All right. Next question comes from Matthias saying, why aren't you using Seaborn for the plots?
Yeah, it's a good question. Seaborn is also a great way to visualize data. It basically boils down to personal preference. I'm quite comfortable and happy using Plotly. I think Plotly also is sometimes a bit more intuitive than Seaborn, especially more intuitive than Matplotlib. The other cool thing is, and we'll get to it once I start visualizing it in a few minutes, is the cool thing about Plotly is they're interactive visualization. So when you hover over them, you get hover data. If you really want to get into it, you can customize what data is shown with hover. So you can do lots of really cool things with Plotly that aren't necessarily possible with Seaborn. But if you prefer to use Seaborn, I'd encourage you to.
Yeah, plenty of choices available in Python for data visualization. All right. So next question comes from Kior saying, elegant dictionary comprehension. Could we also use the map function instead? I think that was where you were converting things to categorical type.
I'd need to play around with it. I don't know offhand if you could use map. You might be able to as well. And I think there's probably a number of ways you can do it. I wanted to use a dictionary comprehension, but I think you can probably use map. But I can't say off the top of my head. I'd need to experiment, but possibly.
Absolutely. So in Python, there's lots of different ways of doing loopy kind of things. So yeah, have a play around, see how many different ways you can solve that problem. All right. Next one comes from Nuan saying, how do we convert categorical data into hierarchies for visualizations?
It's a good question. I think the way you probably want to do it by hierarchy is you can perform aggregations upon multiple columns. So later we'll get into grouping. I don't think we'll be doing much in the way of grouping on multiple columns, but you can certainly create hierarchies when you start grouping by different categorical columns. If you want to group by one and then another, you can create hierarchies, for example, of employment status, and then by an additional level of marital status or things like that. So I think your best option for this is probably going to be using grouping by multiple columns.
All right. Nice. So another question from Kyo saying, is binning useful for temperature time series data?
Ooh, good question. I don't know. I haven't worked much with temperature time series data. I would say it probably depends on your application. I think if you're doing something like forecasting, it's probably not going to be very useful because you're probably going to lose a lot of information when you start binning it. If you want to show general trends and it simplifies it, maybe. I think it really depends on your visualization purposes, but also your analytic purposes. So if you're doing any kind of predictive modeling, probably not, I would think. But there might be instances where it is helpful. I think it really depends on your application. I don't know, Rich, you have experience with, I think you did temperature time series data in our pandas course, if I recall correctly.
Yeah, so absolutely agreed with what you said. It does depend on what you're trying to analyze and the question you're trying to answer. So with any time series data, quite often you want to think of time as being a continuous thing, particularly when you're doing predictions about the future. But sometimes for reporting purposes, you might want to break time up into discrete blocks. So for example, it's very common to have a quarterly report, and you might want to break up what's been happening in your business by month, or same for an annual report. So you'd have January, February, March, whatever. And that's also true of temperature. So if you look at, for example, what's the weather like, or what's the temperature like in a specific place, you might want to say, well, this is the average for January, this is the average for February, March, and so on. So you are binning the time points in that case. But sometimes it would just be nonsense. All right, let's move on to the next question. Another one from Nuance saying, how do you find trends with categorical data? Now, that is an interesting question.
That's a good question. Well, I think we'll largely be covering that in the next section. I think one of the best ways to do it is visualization. So we're going to spend the next little while playing, now that we've gone through the hassle of creating and cleaning all of our categories. One of the first ways to start trying to spot trends is just visualizing it. It's much easier to identify trends and patterns in your data with a good visualization versus trying to root through tables and with summary statistics and things like that. So we're going to be covering that soon.
All right, two more questions, then we'll move on. I think this one's fairly quick. Yevin asks, will we be using scikit-learn and I think one hot encoding and explaining if there are any benefits to this?
It's a good question. We won't be covering one hot encoding in this training. It didn't make too much sense because we're not going to be doing any machine learning. I don't think I've ever one hot encoded data for visualization purposes. I think I've mostly only ever done it for modeling. There might be instances where it's useful for visualization, and it's certainly a good skill to have. But indeed, that's an important part of being able to work with categorical data. At the end, and I think we're sharing resources on it, there is the course working with categorical data on Python. I think the final chapter focuses a lot on one hot encoding. And just for context, one hot encoding is basically taking categorical data and turning it into numerical into numerical columns that can be used by things like machine learning algorithms. So really good question. Not in the scope of this training today, but indeed it's a really important skill. Yeah, great question.
Yeah, I've just realized we've got a tutorial on that. Let me just put that in the chat.
I think we also have a workspace template as well.
Okay, so I put a link to the relevant tutorial. Yeah, there's workspace template. We've got all sorts of resources on this. I think it's covered in several different Python machine learning courses as well. So if you're interested in one-hot encoding and working with categorical data for machine learning, please do check those out. All right, last question before we move on from Tiago saying, when you use pandas interval index to create a new column, does the new column go to the index?
No, the new column is just a separate column on its own. The index of the data frame is untouched. This is just, I actually don't know exactly why it's called an interval index. There's probably a good reason for the naming convention. But no, what we're basically doing is we're just creating these intervals that we can then use to pass into pandas cut. But the index of the data frame is untouched.
Yeah, I think you can assign the results of interval index to the index of your data frame, and then go in the index. But so it's sort of originally designed to be for a specific type of index, but you can also use it to create a column.
I did not know that.
All right. Okay. With that, let us move on.
Okay, great. Okay, so let's jump into actually visualizing our data. So the first thing we're going to cover is bar plots. Bar plots are like a staple of visualizing categorical data. It can be used to visualize. They can be used to visualize counts of the values within a categorical column. They can also be used to return averages across different values of a categorical column. We're going to start by just visualizing the value counts. So we already use the value counts method to return the counts, but sometimes a picture is worth more than a table. So let's create a new figure object, and we're going to use plotlyexpress.bar. We're going to pass in our labor status clean column. We're going to pass in the value counts. One other thing I will add is the parameter template, and we'll use plotly white. Now I'm going to update the layout. This is optional, but you can use the update layout method and show legend equals false. And that's just going to drop an unnecessary legend, because as you'll see from the plot, after we call fig.show. Oh, oops. I think my session restarted, so I just need to run things again. It's a good lesson here. If it says that something is not defined or imported that you believe is imported, it could just be that your session restarted. Okay, so I've restarted everything again, and we've run this plot, and we see we have a bar plot. So it's basically the same thing as before, but you have a visualization of it now. So you can also, as I said before, when you hover over it, you can see the values. It's not very useful here, but with plotly plots, you can also zoom in on particular regions. Not very useful for a bar plot, and you can double click to pan back out. But when you have time series data or something like that, where you want to zoom in on a particular period, the interactive functionality of Plotly is kind of fun. This is okay. I think we can do a bit better though. With bar plots, what I actually prefer to do is set the categories on the y-axis and then the values that we're plotting on the x-axis. I think that gives the column names a bit more room to breathe. So what I'm going to do is I'm actually going to just copy and paste this code up here, but adapt it a little bit. So I'll just call it that. I'm going to pass in a few things. I'm going to set the orientation to be H for horizontal. I'm going to give it a title, which is labor status by count. And if you can think of a better title, please go ahead. And one other thing I'll do is I'm going to set ascending to be true on the value counts. And this will change the order so that we see the most common category or value at the top. So if we run this, we now have, I think, what is a nicer plot where we have all of our categories on the y-axis. And this is also especially useful when you have long category names and it gets a bit ugly and the labels get rotated. So for example, if I were to plot this without the mapping and you run this, you see everything gets rotated a little bit with our original category mapping. So this is often a cleaner way to be able to show the data. You can also use bar charts to show averages of a numeric column. So for example, let's say we had our household size by decade. I'm going to create a variable called that. We're going to take our data frame and group it. I'm going to group it by the decade. I'm going to set an argument as index to be false. By default, grouping will set your grouping column to be the index. If you don't want that, and sometimes you don't because in our case, it'll just return a series and it won't look very nice in Workspace, but also sometimes it could be a hassle to work with indexes. You can set as index equals false, and that'll preserve the column as a regular column rather than setting it as an index. And then we're going to take our household size column, which is a numerical column, and I'm going to take the mean. If I run that, we get the mean household size over time. And we actually already sort of see a bit of a trend where the average size of the number of people in people's household is declining over time. So I'm going to create another bar plot. Household by decade. We're going to pass in the data frame this time, not the value counts. We're just going to set the data frame that we've set. This time we're going to manually set the X and Y axis, which in our case is going to be the decade. And on the Y axis is going to be the household size. And then let's set the template to be plotly white. And one other thing we'll want to do is give it a title. Average household size by decade. Okay, we should be able to run this and get plot of household size by decade. So here we can visualize, there was a question earlier about trends, a little bit of a trend here where over time by decade, we're getting a reduction in household size. There was a question here about hierarchical data. I wasn't actually going to include this, but just to show you, if you wanted different levels of it and you wanted to enrich your plot a bit, you can actually change the grouping variables to have two groups. So if we want to group by decade and then also our degree clean variable, we can run that, and then we're going to get a different value for each of the years. And then we can actually add an additional argument here to be, what is it, degree clean. So we can add an argument to the color parameter, and this is going to split it up so we get different bars for different levels of the degree clean. So we run that, we're going to get, I think, a stacked chart. That's a bit harder to read, so you can also add another argument to this, which is bar mode, and I think it's called group. And if you run that, then you can actually look at per year, what is the difference in reduction in household size per different category of respondent. It looks like it's sort of the same thing. It's sort of the same reduction for both, but this can be a nice way to spot trends within groups and sort of perform a hierarchical aggregation, which was asked about earlier. Another plot type that you can use this is more to inspect your data, is a box plot. This is a good way to inspect distribution of quantitative variables. But what's nice about categorical box plots is you can actually supply a category and visualize the distributions of a numeric variable across different categories. So a good example of this will be to create a box plot. We're going to take our data frame, and what we're going to do is we're going to look at the age column. So we're going to look at the distribution of age, but we're going to split that by labor status, in our case, clean. Again, template equals plotly white. So if we run this, what we're going to get, I have any typos, is a number of box plots for the age. And this allows us to perform a sense check on some of our quantitative variables, such as age. So what we're looking at here is these boxes here are the middle 50% of the data. And these edges, I think they're called the whiskers, are the minimum and maximum, and then the dots are the outliers. But we can use this to do a sense check. So indeed, the middle 50% of people who are retired, the bulk of them seem to be 70 to 80. There are a few people that seem to be retired rather young. I'd like to know their secret. School, it's a much lower age range for people who are students. For people who are employed, it's ranging between, the middle 50% is ranging between 30 and 50. So you can see that your quantitative data makes sense, and you get a quick visualization of that when you use a box plot. So it's another great way to use categorical columns to enrich your analysis and to inspect your data. The next plot we're going to cover is a mosaic plot. I think, yeah, we've got 6 minutes. A mosaic plot allows you to look at the relationship between two categorical variables. And basically what they're doing is they render a visualization of a frequency table between two categorical variables. So I'll give you an example. If we use the function crosstab and we pass in two columns that we're interested in our case, let's look at degree clean and law enforcement clean, and we run this, we'll get a frequency table between the two categorical columns. So we have too little in high school, or we have the different responses to law enforcement across high school and college and university. It's interesting, but it's hard to really know whether there's a higher proportion of people who are satisfied with the spending on law enforcement between high school and university. This is where a mosaic plot can actually really help give a sense of proportion between the different groups. So as I said before, Plotly is not very friendly for creating mosaic plots. Fortunately, there's the function that we imported from stats models that is. So I'm going to pass it our data frame. I'm going to pass in the two columns that we want to look at, which is degree clean and law enforcement clean. And I'm going to pass in a title, which is law enforcement opinions by degree. Then just like with matplotlib, I'm going to call plt.show. And here is our mosaic plot. And here you can quickly see the advantage of this. First of all, we see on this x-axis the proportion of people who are high school versus college or university, but also we can quickly compare the proportions of people who are satisfied with the spending for people who have a college or university degree versus people who are just or who have a high school education. So basically, we can get a sense already very, very quickly that is pretty hard to tell from this frequency table that more people are satisfied with the spending on law enforcement amongst college and university versus people with high school. So this is a really nice way if you have two categorical variables and you want to look at the relationship between them. I think I have a little bit of time. The final chart I'm going to cover is a line plot or a line chart. Now, line charts typically visualize the relationship between two variables, one of which is oftentimes time. It's not always, it's just about a series of connected data points, but time is a very common thing to include on the x-axis of a line plot. We're going to do that. We're going to look at marital statuses over the years. So what I'm going to do is I'm going to take I'm going to create a data frame called marital rates. I'm going to take our data frame and group it by the year. Again, I'll set the as index to be false. I'm going to take our marital status, and I'm going to take the value counts, and I'm going to set normalize to true. And I'm going to look at this resulting data frame. I call this Marshall rates. I want to be careful of that. So if I run this, what I'm going to do is I'm going to look at the proportion of people who indicated their different marital statuses over the years. So if you look for all of the 1972 values, this will all add up to 1, this will add up to 1, et cetera, et cetera. We can now visualize the change in marital statuses over the years because I did some reading on this to ensure it earlier, but indeed marital rates have declined. So we should be able to see this in the survey data. So what I'm going to do is I'm going to create a figure object just as I did before. I'm going to use the line function. I'm going to take our marital rates data frame. On the x-axis, I'm going to set it to year. On the y-axis, I'm going to set it to the proportion. I'm going to set the color to be the marital status. And I'm going to set the template to be Plotly white. One quick thing I'll do is I'll update the y-axis. So I'm going to use this method, and I'm going to set the tick format to be 0.0%. And this basically tells Plotly to render these proportions as percents rather than as decimals. And then I'll call fig.show. And sure enough, we get a line plot where we can actually see the percentage of people indicating they're married declining over the years, and the proportion of people indicating that they've never been married increasing over the years. And same way that looks like divorce rate. So we actually sort of are able to show sort of this fact that's, I think, verified elsewhere, that marriage rates have declined over the last 50 years or so in our survey data, which is kind of cool. That's everything I had for today. One last thing I want to quickly plug. we have a new function, a new feature in Workspace called Generate. If you're ever unsure about code, you can use the Generate feature and ask it to give you the code to create something. So give me the code for a line plot in Plotly. It might take a little bit to run, so maybe we don't have, oh, it's already spitting it out. It'll generate the syntax, and it's generally pretty good. It usually works pretty well. So if you're ever unsure, try this out first and run it. It'll generally come up with something that's pretty good that you can adapt for your own purposes. So all I need to do is click accept and run it. And sure enough, I've got a line plot in Plotly. Okay, with that, I think I'm already at time, but I think I'll take a few more questions if you're around, Richie.
Yeah, Justin, I know you had like a hard stop at time. Are you okay to?
I'm good to take a few questions. I realize I went a bit long.
All right, super. In that case, the next question is about why you're using PX, not PLT, at the start of your plotting code.
Yeah, that's a good question. It's because so PLT is I think the standard alias for matplotlib. We're not using matplotlib here. We're using it once to render the plot generated by stats models. But we're actually using Plotly Express. So at the beginning, and I probably should have gone over this a bit more slowly. We're importing Plotly Express as PX. So we're actually calling Plotly Express functions, not matplotlib. So our visualizations are all being created with Plotly Express, which has been aliased as PX.
All right, nice. And next question comes from Abdul saying, do I need to make conversion, or do I need to convert categorical data to factor in Python? I think this might be an R thing.
Okay, yeah, I think R factor is the R data type, right? I will say, just to clear up something that I probably wasn't clear on, a lot of this stuff you can do by leaving your data types as objects at the beginning. The advantages of categorical data is that it can make it easier for plotting and stuff like that, and it also saves memory oftentimes. It's not absolute necessity. It can just make things easier later on. So you don't need to necessarily convert your object data to categorical data if you're not going to experience a lot of benefits from the ordering or the memory savings.
And worth noting that that's very much a Python thing, or at least a pandas thing, that all your text data starts off as object, and then you have to convert it to categorical. All right, so can you explain how to interpret a box plot and when to use it?
Yeah, absolutely. So we'll go back to it. Basically, what we're visualizing here is this will show the middle line here is showing the median. This box here is showing the middle 50% of the data, so sort of where the middle 50% of the values are sitting. This is the minimum and the maximum, and then these points are the outliers of the data. So basically, when you're trying to interpret this, you can say, okay, well, for employed people, the minimum is 18 up until 81, and then we have some outliers that are through up to 99. But you can see that the bulk of the employed people, so the middle 50%, are ranging between 30 and 50. So you'd use it oftentimes when you want to get a quick idea of the distribution of your data. And what's really nice about box plots is that they're really good for when you want to split apart a numerical variable by another categorical variable. As you can see, it's pretty easy to quickly compare these distributions between different employment statuses. Whereas with a histogram, you'd have to do something like plot them all at once, which can get crowded, or split them up into subplots, which makes comparisons sometimes a bit more challenging. So box plot can be a really nice way to look at the distribution of a quantitative variable.
Fantastic. And just while we're talking about plots, Jubran asks, would a tree map work better than a mosaic chart?
In this case, I don't think so. As far as, to the best of my knowledge, a tree map is better for hierarchical data. And in our case, we weren't using hierarchies. We're just looking at the proportion across two categorical variables. So tree map is another way to look at categorical data, but I think it's, correct me if I'm wrong, Richie, best suited to hierarchical data than what we were using here.
Yeah, I think you're right. And from my perspective, it always takes me about 10 minutes for staring at a tree map to try and work out what's going on. I find them very difficult to interpret. So yeah, mosaic plots are a little bit easier to see what's going on. All right. So we've got question from Aman saying, would you use inferential statistics or would you just do summarizing? So yeah, what kind of like stats can you do on categorical data?
Yeah, I think that's a little bit beyond the scope of this training, but I think we have some good courses that actually go into the things that you can then start to do, like performing t-tests between groups and ANOVAs and other types of statistical tests that you can then start doing to tease apart relationships in your data. Because indeed, right here, we were just doing summarizing and aggregation, but sure, there's a lot of things you can do once you start categorizing your data and you've cleaned it up.
Absolutely. So you're going to want to take hypothesis testing in Python or the equivalent hypothesis testing in R, and there you'll learn about all different tests you can do. All right. And final question then. We go. So when you're doing data frame value counts, can you also use this on the whole data set, or is it better to do it on single columns?
It's a good question. I think there is a method for value counts, but I don't know if it returns useful. Yeah, I don't think it's incredibly useful. What I've done in the past, and I don't know how you've done it, Richie, is sometimes I've iterated through all of the columns that I want and then called the value counts method if I want a quick summary on everything. I don't think, I'm trying to look at what the...
Yeah, so it's basically finding unique rows and then the counts of those. So it's an odd thing when you do it on the whole data set.
In the past, if I want to quickly do the value counts of every column, I've just done something like for call in and then listed the columns that I've wanted, and then just called the df called up. Oops. Something like that, and that'll print a bunch of them, and then you can quickly skim through them. So that might be one way. It's not very beautiful. Another option is you could create a series of subplots in one visualization, do the value counts for each one. So you could, I think there's in Plotly, you can do facet plots or something where you could split it up and create a large visualization of a bunch of smaller plots, which might also be clean. It depends on which columns also you're most interested in. Might not always make sense to look at the value counts of everything if you're only focused on a few specific columns.
All right. And I think with that, we're done. So thank you very much, Justin. For everyone who is interested in more sessions, tomorrow we've got a session on DataCamp Workspace. It's called Supercharging Your Data Workflow with AI in DataCamp Workspace. So we're going to be talking about the GPT-based features that are being included in DataCamp Workspace. And then on Thursday, we've got a more business-focused session on building a data strategy. So please do show up for those. You can go to datacamp.com/webinars to register. Hope to see you again soon. Thank you to everyone who asked a question in the chat. Thank you to everyone who showed up and watched this. I hope to see you all again soon. All right. Cheers. Bye.